Hey boys and girls, welcome to Think Different Television. Alright, here we go. Here's episode 1. Function or not a function, that's what we're going to start out with right here. So, read the directions with me. For each graph, state the domain and range of the relation. We'll get to that in a second. Then explain whether the graph represents a function. So, we got 38, 39, and 40. Function, not a function. Function or not a function? What do you think? Write down what you think. Well, right here, take a wild guess. I'm going to explain in a second. Alright, here we go. 38. This is not a function. So, not a function. In your notes, I want you to sketch this very similar to what it is. So, draw your XY chart, draw your line, and then draw your shading right there. I want you to draw it in your notes. Pause the video if you need, okay? So, why is it not a function? Well, if you look at a graph, you can use something called the vertical line test. The vertical line test will tell you whether it's a function or not. And so if I draw a vertical line like this, so watch me, I'm going to do it in orange. Whoop! If I hit more than one point, then it is not a function. So I hit a point of the graph right here, but all of this also is all these points. All these points are also solutions, so that's why it is shaded. So here's another point, 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 etc. So there are obviously more than one. There's actually an infinite amount of points that it hits. So this is not a function. Okay, vertical line test right here. Does it hit? Okay, so I'm in 39. Whoop, that's just 1 point if I draw a vertical line. Do I ever hit 2 points? More than one? No, I only hit 1 point. Every vertical line I draw, I hit 1 point. I never hit 2. So this is a function. Every input has one output. How about this over here? Function, not a function. Now you know, vertical line test. Do I hit 1 point or more than 1 point? Whoop. Oh, let's draw a vertical line anywhere, whoop, like this. And so I have, it hits 2 every time, my vertical line. So this is not a function. How do you think you did? Did you get them right? Oh, let's see. Okay, let's dial it back a little bit. So check this out. This is the first page. Oh, sorry. Here's your first page in your 1.1. So this is 1.1 right here. So I'm looking at this example of meteorology. Okay. So here is my chart. So this is all the unseeded clouds and seeded clouds. So a meteorologist is someone who predicts the weather, who looks at weather patterns and climate change, etc. So I'm looking at meteorology here. It says state the relation and domain and range. Okay, I told you we'd get back to domain and range, so here we're at. So looking at this chart, here are the answers right here. So this box right here, I'm going to draw, this is the answers. So it's really cool, the textbook, they have the answers right there for you the whole time. Man. Okay, so all I got to do is decipher what's going on. So relation is 28.6, 119. So 28.6, 119. Boom, that looks like an ordered pair. 26.3 and 118.3. Oh, it's just listing all of the ordered pairs. Huh. So in my notebook, it also has a definition in the textbook also. A relation is a set of ordered pairs. And it says that in your textbook also. So boom, that's one thing you should write down in your notebook. Okay, next, domain. What is the domain? I don't really know. So here's an example. So it's got 1, 4.9, 11.5, 7.3. Oh, 1, 4.9. They didn't write it twice. They wrote it once because I guess writing it twice would be redundant. 11.5, 17.3. Oh, the domain is all the x values. Yes. So here's the x, here's the y. And so I think I know what the range is now. 4.1, 7.7, 31.9, 4.1, 7.7. Oh, they have it in least to greatest order. I don't think the order matters, but we got it. So that's all the y values. The range is all the y values of a relation. Okay? So we got those. So now I figured it out. We worked backwards in the textbook. Beautiful thing. Okay. Let's keep it going. Okay, here's example 2. So obviously here is the answer. We're going to decipher how to get it, all right? So reading up here, starting with read along with me, example 2 in your textbook or up here on your screen. The domain of a relation is all positive integers less than 6. So integer is on a number line. So positive integers less than 6. Okay, so I'm going to draw a chart. X and Y. Positive integers less than 6. So it can't be 6 because 6 is not less than 6. So I'm going to start with 5. Then I got 4, 3, 2, 1. Why am I stopping there? Because it says positive. 0 is not positive and negatives are obviously not positive, so there we go. Okay. The range y of the relation is 3 less than x. So here's x, which is 5. 3 less than that, 5 minus 3 is 2. The range of y in relation is 3 less than x. So 3 less than x. Oh, actually, so 3 less than 5. That's what it means. So 3 less than x. So 3 less than x, that would be negative 2. Okay, so 3 less than 4 would be negative 1 here. I think we see the pattern. 3 less than 3 would be 0. 3 less than 2 would be 1, and then obviously this is 2 because I see the pattern going down. Got it. Okay, so we have the domain here is the x, and we got the range. Okay, what else does it have? Write the relation as a table of values. We just did that. And as an equation. So that's y equals 3 minus x. So the y values, the range, is 3 minus the domain. 3 minus 3 less x. Okay? Now we need to graph. Okay, we can graph them. We can do this roughly, but I think we can do it. Okay, 1, 2, 3, 4, 5. 1, 2, 3. Negative 1, negative 2, negative 3, etc. Okay. 5, negative 2. 1, 2, 3, 4, 5. 1, 2. Bam. 4, negative 1. 1, 2, 3, 4. Negative 1. 3, 0. That's my x-intercept. 2, 1. Bada bop. And 1 and 2. So here are my points right here. Got it. All right. So there we go. I answered the question. I got the same thing as this. I checked my answers. Boom, it looks the same. We good. I know my table is out of order, but it doesn't matter since they're ordered pairs. We good. Okay, let's continue. Whoop. All right, here's number 5 on the page of problems. So here's a problem exactly like it, okay? So we just did a problem like this. I want you to pause the video and see if you can get it. I'm going to continue in a second. Pause the video right now. Go. All right, let's check it out. So x and y. The domain, which is the x, is all positive integers less than 8. So that would be 7, 6, 5, 4, 3, 2, 1. We got it. The range is x less 5. So x is 7 less 5 would be 2. 6 less 5 would be 1. 5 less 5 would be 0. And 2, 1, 0. I can just see what's going on. After this, negative 2, negative 3, and negative 4. We got it. So I can keep going with that, or I can do 4 less than 5, and I got negative 1. Okay? So we got the table. We want the equation. Y equals x less than 4. Got it. One thing we're missing is the graph. Okay? No problemo. No problemo. I think we good. Okay, so the graph would be 1, 2, 3, 4, 5, 6, 7. 1, 2. 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5. I could draw these over here if I want, but I have no points over there, so it doesn't really matter. Okay, so 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, bam. 6, 1, don't. 5, 0, don't. 4, negative 1, whoop. 3, negative 2. Math is all about patterns. Once you see the pattern, you just lock it in, right? Doot. 1, negative 4, doot. And it should be linear like that if I were to connect the dots, but we're not connecting the dots, we just graph the relation, okay? Got it! All right, a couple more. Here we go. Doing good. Doing good. Okay, state the domain and range. Domain is all the x, range is all the y. So write this down, copy this in your notes, okay? Just draw a sketch of it. You can do that. Pause the video if you have to. Okay, so domain is the x value. So here's the x right here. Okay, so this line means it extends like this and this. So it goes forever to the right and forever to the left. So the domain is, so it's x equals all real numbers. That means every single number. That means a half, that means pi, that means negative a half, that means negative a third, that means negative 100,000, that means positive 100,000, that means every single x value. So this is all real numbers, okay? Range. Range. So that's the y, right? So that's up and down. So this is going to go this way, and it's never going to, it's going right, but it's also going up. So it's always going to go up that way, and here it's going to go left, but it's also going down forever. So it looks like the y is going to go up forever and down forever, so that's every y value also. So it's all real numbers. That's what that means, all real numbers. We got it. Here's the answer right there. Thank you very little. Okay, here. Next one, copy this in your notes. We got the v. This is an absolute value function. This is y equals absolute value of x, in case you were wondering. We're going to go over that in a little bit, about a month or so, but we're going to get it right now. So domain and range. So domain is all x values. So I can extend this line if it helps me. So x is this. So does it ever stop going right or left? No. So x equals all real numbers. This is going to go right and left forever. It's going to hit every x value. It's going to hit 1, it's going to hit 2, it's going to hit 3, it's going to hit 4, it's going to hit -1, -2, -3, -1,000, etc. Okay? Range. So that's the y value. That's up and down, right? So up and down. So it doesn't go down forever. Oh, man. Okay, but it does go up forever from here. So it's going to go up forever, ever, but it doesn't go down anywhere in this area here. So that's going to be y is greater than or equal to, because it touches 0 right there, and 0. So it's anything above 0. So like a y value could be 2. Y value could be 3. Y value could be 4. Y value could be 5. Y value could be 100. Y value could be 101.1, etc. All those values. Okay? Next. Almost there. Okay. So, what are we going to do? We're going to find out whether the domain in range is a function. Okay, so a function. A function, we just did the vertical line test, but it's a function is a relation in which each element of the domain is paired with exactly one element of the range. So each input, oops, sorry, misspelled it. Each input has one output. Write that down in your notes, pause the video if you have to, okay? So the first thing first. So example 4, state the domain and range. I'm not going to go over that because you see all the domain is the x values and the range is the y values. We got that. So the domain is -3, 4, and 2, and the range is 0, -2, -6. So we got it right here. That's easy. Is it a function? That's the thing we're going to do. So I always look at it like this if I want to. -3, 0. I'm rewriting these points. 4, -2, and 2, -6. So does the input, does the x have a different output? No. All the x's are different and all the y's are different. So this is a function. Each input, each x value has exactly one output. Got it. Okay. So last one right here. So B. Okay, domain and range. Obviously, here's the domain, here's the range. It has it in the answer. So the domain is all the x values, and the y, these are all the range for the y values. Okay. So is this a function? Is this not? 4, -2. Sometimes this helps me, but eventually you're going to sort of get it on your own, where you can just sort of look at it. 9, -3, and -9, and 3. Oh, here's the problem. See, look, here's the input, right? Here's the input, x, which is 4 and 4, and it has a different output. It's got -2 and 2. So, like, if I were to draw this, 1, 2, 3, 4, and then I got 1, 2, -2, so I got 4, 2, 4, -2, 1, 2, 3, 4, -2, bop-de-bop, and then 1, 2, 3, 4, 1, 2, boom, here are the 2 points. It would fail the vertical line test, and every input has an output. So this is not, doesn't have an, every input does not have the same output. It has 2 outputs in this case. So not a function. Why? Therefore, relation is not a function. So here we go. Let's just take it right from the answer. In the domain, 4 is paired with 2 elements of the range, 2 and -2. So right here is what you write down. Here's the verbiage that they want. We're going to give the people what they want right there. Boppity bop, copy that down. Nice job. Okay, here you go. Now you ready. All right, here you go. In your textbook, do page 9, number 5 to 12, all in your notebook. Start with that. Ready, set, go!